So if we want to look at graph transformations, starting with a graph, so a problem something like this, just read through these instructions real quick. The function f shown here, so we're calling this thing f, is a common function type which has been transformed. Note that no stretching or shrinking of the function has occurred. Again, reading this off of a graph can be a little bit trickier. We have to get pretty granular and start like looking at points and how far apart they are and that kind of thing. And it gets to be just a little bit much for right now. We'll kind of revisit that a little bit later in the semester, but for now, none of that has occurred. We want to find the graph, find the function whose graph is shown. So I'm looking for the symbolic version or the equation for the function that's shown here. So the first thing that we need to figure out is what type of function that we're talking about. Again, we have a fairly short list of what we've been calling parent functions or toolkit functions that we're just kind of trying to recognize. So if you don't already see it, now would be a good time to pause the video for a moment, think about what function this is, maybe look back at your notes, um, and take a second to just think through it for yourself before you come back. No fair cheating. I can't see you, but Jesus can. So just take a second and think about it. So I happen to have all of these functions sitting right here. Again, we're just looking for something that has the same shape as the function that we're looking at. So it's this little swoopy thing about which we might make a sound effect like pew as we draw it. So looking at that, this is out, this is out. No, no. We're looking at the square root function. Okay, so I'm just going to kind of make some notes. The parent function is the square root. And if it helps, I could maybe sketch that in here. The square root function looks something like that. So what we're looking for next is how this is different. And I'm just going to list things. I'm going to try not to go in any particular order, and then we'll kind of work on the order thing in a second. It's helpful here to keep track of a point. That looks like a good candidate because I can tell that one apart from the others. That point where it sort of starts looks distinct from others. So how that's different from the function that we started with, it looks like we were at 0, 0, and now we're at -2, -1. So we've gone 2 in that direction, 1 this direction. The other thing that's happening is that the function is upside down, so we've reflected over the y-axis. So we've got a shift to the left 2, down 1, and an x-axis reflection. Again, that holds the x-axis still and flips the thing upside down. So upside down is what an x-axis reflection results in. Okay, now the way those things show up in the function is shift to the left by 2 is +2 on the inside of whatever the action of the function is. So inside the parentheses, inside, in this case, it'll be inside the square root. We generally don't write parentheses with a square root because the stuff inside is treated like it's grouped anyway. The down 1 is a -1 on the outside because it's affecting the y values. X-axis reflection is a negative sign, like a change in sign, like multiplying by a negative. And since it's reflecting over the x-axis or turning the thing upside down, it's affecting things vertically. That's on the outside. And if we want to get into the order of operations of it, that should be something like this then, because of how these work. The +2 on the inside, that's addition, but we're grouping things. That's the whole idea of the inside thing, is that we're grouping things so that that happens first. The x-axis reflection, the negative sign, that's really multiplication, so that would happen next. And then the subtraction at the end would be the very last step. So this is f of x equals negative sign on the outside, big square root x plus 2 minus 1. And then as we discussed in class, once we have what we think is hopefully a pretty good attempt at finding a function that does what we need it to do, I can take this and plug it into a calculator, Desmos, something, and look at the graph. And if it's not right, if it's not the thing that we need, say maybe I goofed up that sign, right, and had x minus 2. Well, then I would see something that looks maybe like that. And then I could say to myself, oh, right, it shifted the wrong way. I moved to the right instead of to the left. I need to fix that by changing this sign. And then, ta-da, we get the function that we need. Okay, great. Hope that helps. Let me know if you have any questions.